All right, we are going to go a little bit through these hydration slides, and I'll explain a few things to you. Okay, so the human body is about two-thirds water. You'll hear things different places like, oh, the human body is 90% water or 95% water, which is just actually untrue. So the human body is actually about two-thirds water. So that's still quite a bit of water that you have in your body. Your muscle mass is about 70% water, right? You've also got water inside of your cells and outside your cells. So two-thirds of the water in the blood is intracellular water, right? That's water that's actually inside your cells. If you think of your cells like a balloon, right? They all have that phospholipid bilayer that we talked about when we talked about lipids, and just by itself, it wouldn't have any shape, right? Just like a balloon. But you fill that balloon with water, and all of a sudden, it has a more rigid shape. Another way I explain this is like when I was a kid, we had an above ground swimming pool, right? 4 feet deep. I think it was like 24 feet across, and the swimming pool shell all by itself just wasn't very strong. But you fill it with water, the water pushed out against the sides and gave it a lot of shape. So that's one of the things that water does in our body, the intracellular water, so in the cells. Another 1/3 of the water in that blood is extracellular, so just floating around between the cells, around the cells. So we do have a lot of water in our muscles. Besides our blood, our muscles is one of our next big storage of water, big places where we store water. And we also store carbohydrate in the water muscles, remember. And for every 1 gram of carbohydrate we store 3 grams of carbohydrate with it, because we can't just store the carbohydrate all by itself. It has to be diluted somewhat. Okay, so we've got all this water in our body. So what does this water do? Okay, one of the things this water does is it provides structure and integrity of the cells, just like we talked about the water balloon or the above ground swimming pool, right? It also delivers things and removes things, right? It's a medium for things to get from point A to point B. It's involved in chemical reactions. It helps us cool our body. It's involved in pH balance. It also contributes to other body fluids such as saliva. Okay, so when we talk about water, one of the big things that we think about when we think about water is, besides delivery and removal of products, is cooling our bodies down, right? So let's talk a little bit about how we gain and lose heat, right? Basically, we create heat through metabolic heat, right? So when you burn carbohydrates or fats or proteins for energy, you're only about 20-25% efficient. The rest is lost as heat, right? So the harder you work, the more heat you're creating, and that is called metabolic heat. The other thing is environmental heat. So environmental heat is heat from rays from the sun, heat from the warm air outside, all those sorts of things. So we lose that heat via radiation, conduction, convection, and evaporation. So we'll talk a little bit about those. Okay, so conduction is direct molecular contact with an object. So that's why, like, your cat or your dog likes to lay down on the cool spot on the floor, right? They lay down on the cool floor, and it helps them cool down, right? Convection is motion of gas or liquid across a heated surface. So that's why hot air or cool air moving across you makes you feel cool. One of the reasons it makes you feel cool. In fact, sometimes you can buy convection ovens that don't just get hot, but they blow air across whatever it is you're trying to cook, and they really heat it up a lot faster. Radiation is infrared rays, so actual rays from the sun, and then evaporation is the one that you probably think of more so, with people. It's as the fluid evaporates, heat is lost. The 580 kcals per liter, I don't expect you to know that. Okay, so evaporation is really important. Really important way to lose body water, and it's really important in cooling our body. So as our body temperature rises, our sweat production goes up. The sweat reaches the skin and it evaporates and cools us down. So evaporation, it's going to account for about 80% of the heat lost during exercise, but only for about 20% of that heat at rest, right? So you're even losing a little bit of water through sweat even at rest, but it's only 20% of your heat loss, right? But 80% during exercise. Okay, so insensible water loss, which is just water through our skin, through our mouth and nose, mucous membranes, that's still going to be about 10% of the heat that we lose. So you're losing heat all the time. Again, you're creating it through all your metabolic processes by burning carbohydrates and fats and proteins for energy, and you've got to get rid of it. Okay, so that sweat is really important. It's important when we're at rest, and it's important, especially important when we're exercising to keep us cool. But dehydration is a potential problem, so not having enough body water is a problem. Okay, yep. Don't really worry about this mechanism for heat balance graphic. Okay, so something else that we really need to be concerned with when we're talking about keeping our body cool and our water balance is that humidity plays a major role in heat loss and therefore the amount of sweat. And it affects our perception of thermal stress. So when humidity is high, the sweat just can't evaporate. So we lose body water and we lose heat through evaporation. But if it's really, really humid outside, the sweat just doesn't evaporate. It doesn't cool us down. And that kind of can create a vicious cycle where you sweat more and you get hotter and you sweat more and you get hotter, but you're not cooling down. You sweat when it's hot in the hot environments and in the humid environments and the dry environments. Like if you're in Houston or Miami and you're sweating, you can feel that sweat all over you because it's not really evaporating. You're having trouble cooling down. Okay, if you're out in Borrego Springs or if you're out in Tucson, Arizona, and you're sweating because it's hot, you might not even notice that you're sweating because it's evaporating so quickly because it's so dry, very low humidity. Okay, so heat balance and our total body water are very closely related. Humans maintain about 97 to 100 degrees Fahrenheit temperature balance. So body heat is transferred by conduction, convection, radiation, and evaporation. Evaporation is the most important exercise. Okay, during exercise, evaporation is the main means of heat loss. During rest, radiation is. So higher humidity also reduces the potential evaporation, and therefore it affects heat loss. Okay, so this is a picture about how our body water moves around when we're trying to stay cool, right? Our blood moves out to the skin. It moves out to the periphery, right? And so when our blood moves out to our skin to try and get rid of all that body heat when it's hot outside, that means that there's less blood for our working muscles, and that's very important to understand. We got the picture of the dog here too. It was just kind of included with a graphic, and I think it's kind of cool. It shows how when it's hot, dogs don't really get this, okay? Dogs don't get their body water, their blood to move out to their skin the way humans do. And nor do they sweat. And that's why dogs pant. That's why dogs breathe heavily when they're trying to cool down. It's not just that they're going hard and they're trying to get in oxygen and get rid of CO2. It's that they're trying to lose heat. Okay. So our body water moves around as we get hot. So what happens is then our active muscles in our skin compete for the blood supply. You only have so much blood to go around. We have more going to the skin. You have less going to the active muscles. So then what happens is our stroke volume of our heart decreases. So with that, our stroke volume is the amount of blood we pump with each beat. So that actually goes down because there's more blood just hanging out there at the skin trying to cool us down. So what that means is that the heart rate gradually increases to compensate for lower stroke volume. This is known as cardiovascular drift. So if you're running at, say, 150 beats per minute, right? You're out there jogging, and it's getting hotter and hotter and hotter. Your heart rate will slowly drift up as the blood moves to the skin and away from the heart and working muscles, because as you get hotter and hotter and hotter, the stroke volume goes down, right? There's less blood pumped with every beat, and your muscles still have the same requirements for oxygen and getting rid of CO2, so they still need the same amount of blood to go to them, so your heart just has to pump more times, but just pump fewer blood each time. Okay, so when you exercise in the heat, you have an increase in sweat, okay? And the high volume of sweat causes your blood volume to go down, it causes you to lose minerals and electrolytes. But one thing that also happens is you release a hormone called aldosterone, an antidiuretic hormone, and what they cause is water reabsorption in the kidneys. So if you're out exercising and it's hot, your kidneys go, hey, let's not get rid of any of this water. Let's keep all we can, right? So that aldosterone antidiuretic hormone, basically it means you pee less because you're saving more of that water. Okay, heat acclimatization is when the ability of your body to get rid of the heat improves. You sweat sooner, you sweat more. Okay, you also have less blood flow going to the skin, which means you have more of that blood and the water available to the working muscles. And actually, as you acclimatize, your blood volume goes up. Your heart rate increase is less than it would be if you were not acclimatized, and your stroke volume increases. That's it. We're going to have to go to the next slide, so I'll catch you in a minute.